Okay, so let's go over some troubleshooting on 4 to 20 milliamp circuits. I've got an inductive proximity sensor here that does 4 to 20 milliamp. So when I put some metal near it, the current reduces. When I take the metal away, the current increases. You can see on the meter, I've got the actual milliamp readout on the meter itself, and then I've also got the PLC readout. Alright, so we've simulated a fault on this 4 to 20 milliamp circuit. The first step is to try and identify where the fault lies. Is it the sensor itself? Is it the PLC? That's what we need to find out. So how do we know there's a problem? Well, a 4 to 20 milliamp circuit, when it's at its minimum value, the sensor is giving its minimum output, we should be reading 4 milliamps. The fact that we've got 0 indicates a few things. Either we've got a wire break, the sensor's gone faulty, or maybe the PLC card's gone faulty. So let's go through a few steps to check these. Okay, so the first thing I want to do is check that the sensor itself is working. Ignore this meter for now, that's just there for the demonstration purposes. What I want to do is take this meter and connect it to the output of the sensor itself and check that the sensor is giving an output that it's supposed to do. So if I click that on there, I can see that I'm getting 24 milliamps. So this sensor is still giving an output. There's nothing wrong with this sensor. It's a little high, it's giving out 24 milliamps, but that's just down to the fact that I've got the potentiometer set on the back quite high. It would normally be set up for 20 milliamps if it was calibrated right. I've confirmed the sensor's okay, the sensor's giving the output it's supposed to. Now it's time to check the other end and check the PLC is reading okay. You might have an issue within your PLC somewhere, the card might be faulty, so it's time to establish that that's working okay. So to do this, I'm going to inject a current into the PLC itself. So I've got a multimeter which can actually output milliamps. If I go on there and go on analog input 3, you can see I'm giving 12 milliamps. The HMI is reading 12 milliamps. I go down to A, it's reading 8. Okay, so we confirm that the sensor's good, we confirm that the PLC is good. All that's left that could be possibly at fault is the wiring in between. So by powering everything down, doing your continuity checks, you're going to find somewhere along the line you've got a wire break. When you fix that wire break, put that back onto DC, move that out of the way, and you can see we have a working 4 to 20 milliamp loop once again. So here's a tip for you. If you want to check the output of a sensor but you don't have a meter that can easily measure milliamp current, if you terminate that sensor with a 250 ohm resistor, you're going to get 1 to 5 volts across that resistor. It's just Ohm's law. If you want to inject a current into the PLC and you don't have a fancy meter, again, put a resistor in. If you put positive on one side of the resistor and you wire the other side to the PLC, if you size your resistor correctly, you're going to be able to generate a small milliamp current. So for example, if you put a 1200 ohm resistor in series with that PLC, you are going to get 20 milliamp. If you put a 2K resistor in series, you're going to get 12 milliamp. It's just Ohm's law, V over